Okay, simplifying the expressions. This is very different than what you just did. What we have to do here, first of all, if you took the square root of 10 times the square root of 20, you would get a decimal answer. We need all of our answers in radical forms. So you can multiply, since these are both under a square root, we can multiply them. So the square root of 10 times the square root of 20 is the square root of 200. And from there it can simplify. If you take the square root of 200, it won't. Again, you'll get a decimal answer. But I know by my perfect squares, if you don't have your perfect square numbers memorized, I highly encourage you to write them down and use them all throughout our classwork tomorrow and throughout these notes. Perfect squares is everything squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. These are all perfect square numbers. And then 64, 81, 100, 121, 144, 169. It will keep going to infinity. So the square root of 200 here, the reason I went down to 100 there is because 100 is the largest perfect square that can go into 200. You always want to pick the largest one, otherwise you're going to have more simplifying that you need to do. So this can technically be written as the square root of 100 times 2, okay? Because 100 times 2 is 200. Well, I know the square root of 100 is 10, and the square root of 2 is a decimal, but I also know that there's not a perfect square larger than 1 that can go into that. So that square root of 2 radical is in simplest form. So your answer here is 10 square root of 2. Now, as far as cube roots go, now again, those are both cube roots, so we can multiply them together. If it was the cube root of 16 times the square root of 20, we couldn't do that because these aren't the same radical. These are. Again, because it's a cube root, now we need to know our perfect cubes. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed I believe is 125, let me check, is 125, 6 cubed is 216, and then that keeps going. 7 cubed is 343. Same rule applies here. You want to do 16 times 20, and that's the cube root of 320. And then we need to find the largest cube root that can go into 320. So the first thing I'm going to do, I'm going to take 320 divided by 2, and it's 160. So I know 216 definitely doesn't go into 320. Maybe 125 does though. 320 divided by 125 doesn't work, 2.56. 320 divided by 64, that's 5. That one works. So this can be rewritten as the cube root of 64 times 5. Well, the cube root of 64 is 4, so we'll have 4 cube root of 5. That's that in simplest form. And here 15 times 14, again they're both square roots, so we can do it. So we have the square root of 210. Alright, so 100, well I guess 210 divided by 2 is 105. That doesn't work. 100 won't work. 81 might, probably not though. Nope, doesn't work. Let's try 64. Also doesn't work. Let's try 49. My guess is that won't work. And it doesn't. Let's try 36. That doesn't work. Let's try 25. That doesn't work. Let's try 16. That doesn't work. Let's try 9. That doesn't work. Let's try 4. That doesn't work. So I guess that's it. That is in simplest form because there's not a perfect square that works unless I did something wrong as I was dividing here. So let me double check again. No, I think we're good. So that's in simplest form. You can't do anything with it. You can't break down. Okay, so same thing that we did previous lesson, except now we're adding this extra piece of multiplying. By all means, you can simplify first and then multiply. What I mean by that, this can go to x squared y cubed, as we already figured out from last lesson, because remember that's x to the 4th, y to the 6th, raised to the 1/2 power. 4 times 1/2 is 2, 6 times 1/2 is 3, because that 1/2, using the properties of exponents, that 1/2 is distributed to both. And then we have times 3, and then the square root of 2 is going to stay, but, and this is where it might get a little confusing. So I'm going to actually rewrite this differently. The square root of 2 can stay, because that can't be simplified, which we learned just the previous slide. Now the square root of 8, or the square root of x to the 8, we should know is x to the 4th. 8 times 1/2 is 4. Now, if we did 5 times 1/2, we'd get 5/2. So that doesn't go into it evenly, but I can rewrite that as y to the 4th times y to the 1st. Well, the square root of y to the 4th, so 4 times 1/2 is 2. So I can take out y squared, but underneath the radical, I'll still have that 2, and I'll still have this remaining y. So all that's left now is to multiply. And again, properties of exponents. 3 times 1 is 3, and I can't multiply 3 in the square root of 2 because the 2 is under the radical. So it's 3 times 1, x squared times x to the 4th, that'll be x to the 6th because we add our exponents. Y to the 3rd times y squared is y to the 5th, again because we add our exponents. And then we've done all this, so then it's just we're going to add the square root of 2y. And I don't need to put absolute value symbols around the y because it says assume all variables are positive. So I don't need that absolute value symbol. So this would be the answer in simplest form. Now I said you could have multiplied first and got that same answer. So I could have multiplied all that and I would have got 3 square roots of 2x to the 12th and then y to the 11th. Okay, so whichever way you find faster, you can do this. So when I do x to the 12th to the 1/2, I get x to the 6th. Again, same rules apply there when I did y to the 5th. Y to the 11th, I can't do 11 times 1/2 is, what is it? 11 halves, so that's 5.5. So I have to break that up as y to the 10th times y to the 1st, and then 10 times 1/2 is 5. So that's where y to the 5th comes from. So I still have this remaining y underneath the radical and that 2. So it's still the same answer, but whichever way you like better to get to that final answer. Okay, we'll have problems like this. The square root of 3 times 5. Now that you can actually multiply, but it's not the square root of 15. It's just 5 square root of 3. You can't, so multiplying them is just basically putting them together. And then plus, now the square root of 3 times the square root of 21, since they're both under the radical, that can change to the square root of 63. Which, to simplify that, I know 9 goes into it. I'm just checking to see if there's anything bigger, and it's not. So there's no perfect square bigger than 9 that goes into 63. So this will simplify to 5 square root of 3 plus 3 square root of 7. How would I get that? Because we'll have the square root of 9 times 7, and the square root of 9 is 3. And then we'll still have the 7 underneath the radical. Now that is as far as that can go. I can't combine those. You'll learn next lesson that if this was the square root, or 3 square root of 3, we could simplify, go one step further. Because it's kind of treated like a 5x plus 3x. So since the same number is underneath the radical, you can add them further. In this case, we can't. Like I said, we're going to learn that next lesson. So there's our final answer here. this, again, either way you want to do it. You can multiply first and then simplify, or simplify first and then multiply. In this case, I'm going to multiply first, and it's only because I can see that we're doing square root of 20 times square root of 20. Because I know doing that, I'm going to get the square root of 400, which I know is a perfect square, and then I'll have x cubed. Okay, so square root of 400, when you take it, you get 20. And then we have the square root of x cubed, right? But that can be rewritten as x squared times x. So it's going to be 20x and then square root of x, because 2 times 1/2 is 1. So that's your final answer there. So that's multiplying radical expressions. And so here would be dividing radical expressions. So our properties of exponents with this is, when we're taking a square root divided by a square root, we can write it as the square root of 5x to the 4th y over 2x squared y cubed. And doing that, you can simplify it. Using our rule of exponents, you can divide it out. So we'll have the square root, 5 halves can't simplify. I mean, I guess it could go to 2.5, but you don't want a decimal underneath that radical. X to the 4th divided by x squared, well, 4, remember you subtract the exponents when you're dividing, so we'll have an x squared on top, and then y over y cubed. So I could do 1 minus 3, which would give me y to the negative 2 power, and then I'm going to move it down below to give me y squared. So this, we can continue to simplify now by taking actually the square root of each piece. So I know that's just going to simplify. We're going to keep the square root of 5, but we're going to have x square root of 5 over here. We'll keep the square root of 2, but it's going to be y square root of 2. Now you might think, all right, great, we're done, but we're not. You can't have a radical in the denominator. That's not simplest form. So when it says rationalize the denominator, it means get rid of that radical. So to get rid of the radical here, we need to multiply by the square root of 2. So this square root of 2 times square root of 2 is square root of 4. And that goes to 2, which will, I'll show you how it simplifies here in a sec.